the next normalization technique in pipeline is G-score normalization, which is widely and heavily used in data science as well as analytics as well as any other software based application also. So in this technique, values are normalized based on mean and standard deviation of the data A. As per the example, we are taking A as the data, overall data set. So the formula is this. So normalized individual value is equal to individual value minus mean of the whole data divided by standard deviation. That's what the G score. So here V apostrophe comma V is the new and old of each entry in the data respectively, and sigma A is the standard deviation and mean of A respectively. Okay. Anyway, this is widely used technique, so that's the reason I want to take an example directly. So let me call upon the data. We have the customer data. Okay, we have age and we have price both. So let me keep the customer data here, customer columns. Yep. And now I'm gonna type it as G score normalization. So let's read. Okay, we have the customer data here, so not to worry. Yep. Let's move on. So now let's perform G-score normalization on a specific column. First, let's target the price column. So let's perform G-score normalization on a specific column. So first let's take the column name. Column name is price. And then let's find out the mean value. Mean value. So okay, customer, that's our data frame, and then price, and let me get the mean of it. So here we'll get the mean. Just I'm executing, and if you want to see the mean value, and this is what the $689, I think it's in, okay, it's not mentioned, it's $689 is the price of mean price of all the products together. Then once the mean value is done, now it's time to calculate the standard deviation. So standard deviation value, this is equals to cost and price and STD, and let me calculate the STD value also. It's 941. The standard deviation value is 941. That's huge. In fact, that's huge. Mean is 689 and then standard deviation is 941. Of course, yeah, that's possibilities. 4,235.58. The prices are high. Okay. Standard deviation is done. Now let's calculate the normalized. Let's convert this complete column into the normalized column and append that column into the data frame. So cost, let me say price normalized is equal to, so first bracket as usual, each individual value, so cost of price, and then minus of mean value, and whole thing should be divided by standard deviation value. And here is your cost. Okay, something is still happening. Cost. That's it. And let me find out the, yep, here is the price normalized. Price normalized. 0.86, 1.18, 2.45, 3.73. Of course, this takes up, it's a G score. It's not in between 0 and 1. It's in between the mean and then one standard deviation. So mean and one standard deviation. What's the one standard deviation that we got? So this is the standard deviation value. I think it's, yep. Okay. So that's what the price normalized. Now let me go for the another column from the same data. So this time I'm going to go for the age. Age. Let me change this to the age. Age. And here, let me convert this into the age normalized. And this one, age, and rest all done. So cust. And let me scroll down and check. And here is your age normalized, and again it's in between the mean. It's 0. Of course, the mean is your 0, and then mean, and then one standard deviation of it. So that's what the 0 and then one standard deviation. That's what you can see, 0 and values here. So let me just check the mean STD value here. STD, it's 14.9. Okay, this is what the average deviation between each person with the mean of the total data. Okay, so now let's use a G score standard scalar from sklearn to do the same thing. Here we are typing hard coding with formula, and there we can directly pull from the sklearn pre-processing module. So from sklearn pre-processing, import standard scalar. So let me take a data here. I think I'll take the same data, which is df. Okay, and let me perform G score transformation on columns A and B. So scalar is equal to standard scalar method or function, then G score of data frame is equal to scalar dot fit transform, and df. So G score, sorry, underscore, sorry, this is, yep, and G score df is equal to pd dot data frame of G score df comma columns, as we have done before, df dot columns. And finally let's print G score df, and here is your G score which is converted, and you can see the 0 and then one deviation on positive side, on negative side, and that's what is called a G score transformation. And here is the example. You see that you got 1 2 3 4 5. So for you the mean is somewhere here, because it's, so that's the reason the center, it's a odd number, so the mean is here. Okay, let's check the mean of A. So what's, nothing wrong there, and it's a mean 3.0, and standard deviation STD, it's 1.58. So that's what we got by and large. Here you got the 0 because the 3 was replaced with the 0 because the formula is what? It's the 3 minus standard 3 minus mean 3 minus mean 3 is again 0. So 3 minus 3 is 0. That's the reason it became a 0. And then the values greater than the mean will has taken up these values. The value which is lesser than the 0 has taken up this. But whatever it may be, the scores has been normalized between minus 1 deviation to the plus 1 deviation. That's it. That's what the G score. That's what the G score normalization is.